Have you ever pondered the infinite expanse of the universe and wondered if it's getting bigger by the day? This question might seem like something out of a science fiction novel, but it's a genuine scientific inquiry. The universe, in all its vastness and mystery, is not stagnant. It's not a fixed, unchanging backdrop against which the drama of cosmic events unfolds. Instead, it's a dynamic, ever-evolving entity that's constantly in motion, constantly expanding. Sounds mind-boggling, doesn't it? But it's this very expansion that's the heart of some of the most intriguing theories in cosmology. These theories don't just seek to explain why the universe is expanding, but also how it's expanding and what this expansion could mean for the ultimate fate of the cosmos. From the role of elusive dark energy to the concept of cyclic universes, these theories are as varied as they are fascinating. So, without further ado, let's delve into the theories that try to explain this intriguing phenomenon. The most popular theory, the Big Bang Theory, suggests the universe began as a singularity. Now, what is a singularity, you ask? It's a point in space and time where the laws of physics as we know them break down, where density and temperature reach unimaginable heights. The Big Bang Theory was first proposed by a Belgian physicist, Georges Lemaître, in the early 20th century. Lemaître imagined the universe as a primordial, superdense and superhot state, which then expanded and cooled, giving birth to galaxies, stars, and ultimately, us. But how do we know this theory holds water? Well, we have some pretty compelling evidence. First off, we see galaxies moving away from us in every direction, suggesting an ongoing expansion. This was first observed by Edwin Hubble, hence the name Hubble's Law. Another piece of evidence is the cosmic microwave background, or CMB. It's a faint glow of radiation that permeates the entire universe, a relic from a time just 380,000 years after the Big Bang. This radiation is remarkably uniform, supporting the idea that the universe started from a hot, dense state. Lastly, the abundance of light elements in the universe, hydrogen, helium, and lithium, aligns perfectly with the predictions made by the Big Bang Theory. This theory paints a picture of a universe that has been expanding ever since its birth. Inflation theory, a subset of the Big Bang Theory, proposes a period of rapid expansion. This theory was born out of the need to explain certain mysteries that the Big Bang Theory could not quite account for. The brainchild of physicist Alan Guth in the late 20th century, inflation theory suggests that, in the mere moments after the Big Bang, the universe underwent an incredibly swift and exponential expansion. This theory elegantly addresses two puzzles that had stumped cosmologists. Firstly, it explains the surprising uniformity of temperature across the vast expanse of the cosmos, a phenomenon known as the horizon problem. Secondly, it resolves the flatness problem, the observation that the universe's density is precariously balanced to prevent either a big crunch or infinite expansion. Inflation theory, therefore, not only complements the Big Bang Theory, but also provides a richer, more nuanced narrative of our universe's birth and growth. Inflation theory adds a twist to our understanding of the Big Bang. Dark energy, a mysterious force, is believed to be driving the accelerated expansion of the universe. This strange energy, making up about 70% of the universe, is as elusive as it is pervasive. Its existence was postulated in the late 20th century when astronomers made an astounding discovery. The universe's expansion wasn't slowing down as previously thought. Quite the contrary, it was speeding up. In the cosmos, gravity, the force of attraction, should have been pulling galaxies closer together, slowing down the expansion initiated by the Big Bang. But observations of distant supernovae, the explosive ends of certain types of stars, told a different tale. These cosmic beacons were further away than they should have been, suggesting that not only was the universe expanding, but it was doing so at an ever-increasing pace. Enter dark energy, a hypothetical form of energy proposed to reconcile the disparity between theory and observation. It's this dark energy, pervading all of space, that is thought to be causing this accelerated expansion. Unlike matter and dark matter, which clump and cluster, dark energy appears uniform, the same no matter where you look. Though we can't see it, and it remains shrouded in mystery, evidence of dark energy is etched across the cosmos, in the large-scale structure of the universe, and in the patterns of the cosmic microwave background radiation. Dark energy provides an explanation for the universe's accelerated expansion. It's a key piece of the cosmic puzzle, helping us understand the nature of the universe and its ultimate fate. Multiverse theory suggests that our universe is just one of many. A rather daunting thought, isn't it? This theory, which emerged from the mathematical framework of quantum mechanics, proposes the existence of multiple parallel universes, each with its own laws of physics. Imagine a cosmic bubble bath, with each bubble representing a separate universe. The concept of the multiverse is not just a figment of science fiction. It's a real scientific hypothesis backed by some of the brightest minds in the field. So what does this mean for our understanding of the universe? Well, it essentially flips it on its head. If the multiverse theory is correct, then our universe, vast as it may be, is just a small part of a much larger cosmic landscape. This theory challenges our traditional view of the universe as a single, self-contained entity. Multiverse theory challenges our perception of the universe as a singular entity. Cyclic universe theory proposes a universe that has no beginning or end. Imagine a cosmos that's perpetually cycling through time, a universe that undergoes endless periods of expansion and contraction. This is the essence of the cyclic universe theory. It's a concept that dates back to ancient Indian and Greek philosophers, but has found modern traction among some cosmologists who see it as a potential solution to some of the biggest mysteries of the universe. This theory suggests that the universe we inhabit is just one phase in an infinite series of cosmic cycles. Each cycle, or eon, begins with a big bang, expands for billions of years, and then contracts back to a singularity, only to bang again. It's like a cosmic phoenix, forever dying and being reborn from its own ashes. What makes the cyclic universe theory so tantalizing is its ability to address some of the problems with other theories. For instance, the Big Bang theory struggles to explain what happened before the bang, while the inflation theory has difficulties accounting for what triggers the inflation. The cyclic universe theory, however, elegantly sidesteps these issues by proposing that there was no before the bang. Each Big Bang is merely a transition from one cosmic phase to the next. Cyclic universe theory paints a picture of a universe in a constant state of rebirth. A universe not bound by the constraints of a single beginning or end, but one that's forever cycling through an endless dance of creation and destruction. Dark matter theory introduces a mysterious substance that makes up most of the universe. This theory proposes that there is a form of matter, unseen and undetected, that fills the cosmos and shapes the galaxies. The idea of dark matter was born in the early 20th century when astronomers noticed something odd about the way galaxies spin. They found that the stars at the edges of galaxies were moving just as fast as those near the center, defying the laws of gravity. This led to the hypothesis that there must be some invisible matter providing the extra gravitational pull. Since then, other pieces of evidence have stacked up in favor of the dark matter theory. We see it in the cosmic microwave background radiation, the oldest light in the universe, which shows patterns that can only be explained if dark matter exists. Dark matter theory adds a layer of mystery to our understanding of the universe. It's a reminder that there's so much more out there, just waiting to be discovered. String theory, a framework that tries to reconcile quantum mechanics and general relativity. Now imagine the smallest particles in the universe, even tinier than atoms, as not just points but as one-dimensional strings of energy. That's the core concept of string theory. This theory was first proposed in the late 20th century as a way to unify the seemingly incompatible theories of quantum mechanics, which explains the behavior of the smallest particles, and general relativity, which describes gravity and the large-scale structure of the universe. In the world of string theory, these strings vibrate at different frequencies, and these vibrations give rise to the fundamental particles we observe, like electrons and quarks. It's a bit like how different musical notes emerge from the vibrations of a guitar string. Now here's where things get mind-bending. String theory also implies the existence of more dimensions than the four we're familiar with, 3 of space and 1 of time. Some versions of the theory even suggest there could be as many as 10 dimensions. But what does this mean for our understanding of the universe? Well, if string theory is correct, it could provide a unified description of all the forces of nature, something that has eluded physicists for decades. It could also shed light on the nature of black holes and the very birth of the universe itself. String theory challenges our understanding of the fundamental nature of the universe. It's a radical idea, but one that could hold the key to some of the deepest mysteries of the cosmos. Quantum fluctuation suggests the universe could have come from nothing. Now, this is a bold idea, isn't it? But how does it work? Well, it's all down to the quirky world of quantum mechanics, where the improbable can become the inevitable. Quantum fluctuation is a phenomenon that sees particles and antiparticles momentarily form and annihilate, pulling energy from seemingly empty space. It's like a cosmic dance of existence and non-existence. This theory was first proposed in the early 20th century and has been a subject of intense study ever since. If you apply this concept to the universe, it suggests that our universe could have sprung from a vacuum, from nothing, due to these fluctuations. It's a mind-bending idea, one that challenges our traditional understanding of cause and effect. It's also a reminder that the universe doesn't always play by rules we're familiar with. Quantum fluctuation challenges our understanding of the origin of the universe. Indeed, it prompts us to rethink what we believe we know about the cosmos. Eternal inflation proposes a universe that is forever expanding. From the far reaches of the cosmos to the furthest corners of our minds, this theory takes us on a journey that is both expansive and intriguing. It's a concept that has been around since the early 80s, and it is attributed to the physicist Alan Guth. Eternal inflation is an extension of the standard cosmological inflation theory. It suggests that our universe is just a small bubble in a grand cosmic champagne, where countless other universes exist, each with its own laws of physics. It's like a never-ending cosmic real estate, where new universes are constantly being born. This idea was born out of the shortcomings of the traditional Big Bang model, which could not explain the uniformity of our universe. Eternal inflation proposes that after the Big Bang, space-time expanded at different rates in different places. In some regions, inflation stopped, and these areas became what we now know as universes. But in other areas, this expansion continues even today, giving birth to new universes. This theory paints a fascinating, albeit mind-boggling picture of our cosmos. It changes the way we perceive our universe from a singular entity to a possibly infinite collection of universes. It also raises intriguing questions about the nature of space and time, and the ultimate fate of our universe. Eternal inflation paints a picture of a universe that never stops growing. It challenges us to think beyond our bubble and explore the infinite possibilities that our cosmos may hold. The cosmological constant, introduced by Einstein, suggests a static universe. This concept originated in the early 20th century when Albert Einstein was developing his theory of general relativity. He added an extra term, the cosmological constant, to his equations to counteract the effects of gravity and uphold his belief in a static, unchanging universe. However, this idea was later abandoned when Edwin Hubble discovered the universe was actually expanding. The cosmological constant represents a property of space itself, the energy density of the vacuum of space. Its implications for our understanding of the universe are profound. If the cosmological constant is positive, as recent observations suggest, it could explain the mysterious dark energy driving the accelerated expansion of the universe. This concept, though initially discarded, has found its way back into the forefront of cosmology, providing a fascinating glimpse into the dynamic and ever-evolving understanding of the cosmos. The cosmological constant is one of the earliest attempts to understand the nature of the universe's expansion. These theories, each with its unique perspective, attempt to unravel the mysteries of our ever-expanding universe. We've traversed the cosmic landscape from the fiery birth of the cosmos in the Big Bang theory to the mysterious force of dark energy, accelerating this expansion. We dove into the inflation theory, which proposes a period of rapid expansion in the early universe. We explored the possibility of countless universes in the multiverse theory, each with unique physical properties. The cyclic universe theory, on the other hand, presents a universe in an eternal cycle of creation and destruction. We delved into the enigmatic dark matter theory, suggesting the existence of unseen particles influencing the universe's structure. The string theory leads us to a universe of vibrating strings, while quantum fluctuation proposes a universe born from fluctuations in the quantum vacuum. The eternal inflation theory captivates us with the idea of infinite universes being created in an eternal inflating space. Lastly, the cosmological constant, a value that Einstein once discarded and later called his biggest blunder, might hold the key to understanding dark energy and the universe's expansion. Each of these theories, in their own way, offer glimpses into the grandeur of our cosmos, its origin, its evolution, and its eventual fate. Yet, none of them provide a complete picture. The universe, in all its complexity, remains a puzzle. One filled with dark matter, dark energy, and countless galaxies, each holding billions of stars with their own planets. But the quest for answers continues. Scientists, astronomers, and cosmologists worldwide are tirelessly observing, experimenting, theorizing, and questioning. With every passing day, with every new discovery, we get one step closer to understanding the true nature of our universe. As we continue to explore the cosmos, we might come closer to understanding the true nature of our ever-expanding universe. Until then, the mysteries of the cosmos remain, waiting to be unraveled. As we draw to a close on this cosmic journey, we're reminded of the universe's vastness and the myriad mysteries it holds. There's always more to explore, more to question, and more to awaken our curiosity. We sincerely hope you've enjoyed this expedition through the cosmos as much as we have. If this video has taught you something new, do show us your support by hitting that like button. Furthermore, we invite you to share your thoughts and opinions in the comments section below. They may just spark a fascinating discussion about the universe's mysteries. You never know, your comment could lead us all a step closer to solving these cosmic riddles. Remember to hit subscribe and tap the bell icon to stay updated on our latest cosmic explorations. Sharing is caring, so don't hesitate to share this video with your friends and family. They might also find these cosmic theories intriguing. Until our next cosmic journey, continue exploring, continue questioning. After all, we each have a role to play in this grand cosmic narrative. From far-flung galaxies to the quantum realm, let's continue unraveling the mysteries of the cosmos together until keep your gaze skywards.